In this video, we're going to demonstrate equivalence, non-inferiority, and non-superiority tests. These are extremely useful tests when the aim of the study is to demonstrate that two treatments are effectively the same, or that one treatment is not inferior or not superior to another. For example, in a medical trial when the aim is to prove that a new drug is just as effective as the standard drug, or in the plant breeding context when the aim is to show that a new cultivar is at least as resistant to disease as the industry standard. Our new menus for t-tests and ANOVA make it easy for you to perform equivalence, non-inferiority, and non-superiority tests. In most statistical hypothesis testing scenarios, the null hypothesis is that of no effect. For example, that there is no difference between two treatment means. The p-value assesses the weight of evidence against the null hypothesis. The smaller the p-value, the greater the strength of evidence against the null. However, as discussed in our blog titled "Never Accept the Null Hypothesis, It's Both Wrong and Dangerous," the null hypothesis is never proven. Equivalence tests solve this problem. They enable us to obtain evidence that two treatments are essentially the same. Similarly, a non-superiority test enables us to obtain evidence that one treatment is not superior to another, and a non-inferiority test that one treatment is not inferior to another. Let's look at an example using the ANOVA menus. The data we'll use is from a plant breeding trial in which the yields of several different wheat cultivars are tested for equivalence against the industry standard Blaze. We begin by performing an analysis of variance with randomized blocks on the yield in tons per hectare variate. After clicking Run, the ANOVA Further Output menu becomes available. Clicking the New Equivalence Tests button opens a menu for performing equivalence, non-inferiority, and non-superiority tests for a selected treatment term in your analysis of variance. We'll assess which cultivars are equivalent in terms of mean yield in tons per hectare to the cultivar Blaze at the 95% confidence level, and we'll define equivalence as the mean yield being within a ton per hectare of Blaze by entering -1 and 1 into the equivalence limits fields. Let's also output a graph giving the 95% confidence intervals for equivalence with cultivar Blaze. Now the menu is populated, we can click Run to perform the equivalence tests. The null hypothesis for an equivalence test is that means are not equivalent. That is, that the difference in mean lies outside the range specified by the equivalence limits. In the output, we see that 3 cultivars have p-values less than 0.05, Encore, Victor, and Warnica. Therefore, at the 5% significance level, we can reject the null hypothesis for these cultivars and conclude that they have mean yields equivalent to that of Blaze. This conclusion is also evident from looking at the graph. The confidence intervals for Encore, Victor, and Warnica lie completely within the equivalence limits. These tests can easily be performed via the t-test menu as well. However, you can also use the procedure t-equivalence directly to perform these tests using output from a different type of analysis, for example, using means, SEDs, and degrees of freedom from a linear mixed model analysis. To learn more about this procedure, check out Genstat's comprehensive help. Genstat 22 offers many more new and exciting enhancements and features. To find out more, check out the What's New page on the knowledge base.